All right, so let's look at this plane. Plane is flying horizontally, kind of like the kite problem. Your plane is perfectly staying horizontal to the ground at 1 mile off the ground. Okay, so here's the ground. This would be 1 mile. Okay. It passes over this radar tracking station and then keeps going. If the distance between the station and the plane, so the plane would be moving along over here, the distance between the station and the plane, so that's talking the diagonal, is increasing at this rate. So this, I'm going to label it D for diagonal, so that the rate that D is changing, that diagonal is changing, is 400 miles per hour. It's getting larger. When that distance is 10 miles, so when that distance D is equal to 10, find the speed of the plane. What is that talking about? That is talking about how fast this length is changing. So let's give it P for plane. So find dP dt. All right, so I think I've got an equation going here, right? So I've got d squared is equal to 1 squared plus p squared. Ready to go. Let's take a derivative. 2p dp dt. 2's cancel. Plug in the 10 and the 400. I'll need to go find the p, but we can do that. Find the p by plugging the d into the equation. So I get 10 squared is equal to 1 squared plus p squared. So that's 99 is p squared. So root 99 is p. So my dp dt is 4,000 over root 99. All right, so let's talk about ships. So at noon, so I've got a little clock going here. It's at noon. We've got ship A and ship B leaving from the same dock. So ship A, here's the dock. Ship A is sailing east, going at 35 kilometers per hour. Okay, so you might be tempted just, to label your ship. And that's fine, not just ship A, but it's your distance, your side length that you really need to have the A beside. Because that's what's changing at 35 kilometers per hour. All right, ship B is sailing north. So again, you can label that guy B, but it's your side length that you need. dB dt is 25. Okay, so how fast is the distance between them changing? So let's label that C and say, let's find dc dt. And when, the when is given in a little bit of a convoluted way. So the when is at 4 p.m. So that's when 4 hours has passed. And I'll do some computations later to figure out what that means. But for now, let's just do t equal 4. All right. So my equation, I can see Pythagorean theorem again. B squared plus a squared. And let's do it. So 2c dc dt, 2b db dt, 2a dA dt. Okay, I'm going to encourage you to get rid of the 2's. And let's start figuring out what's happening. So I have A moving along at 35 kilometers per hour, and it's times 4 hours. So that's going to give me 140. So the distance A will be 140 for 4 hours passing. The distance B will be 100. So let's go put the, and then let's go figure out the distance C while we're at it. Yes? So here's 100. Here's 140. So to find out what C is equal to, that will be the square root of 100 squared plus 140 squared. So let me go figure that out. And that gives me about 172. All right. So I have 172 times dc dt, which is what I'm trying to find, equaling 100 times dB dt, which is 25, plus A, 140 times d80 dt, which is 35. So to solve for dc dt, you would just divide this by 172. So 100. So that's 7,400. Okay, so that's the rate. It is positive. It is getting larger.